Okay, so for our topic today, we have FOLDE. So FOLDE is basically the acronym for first order linear differential equations. Now, the definition of a FOLDE is that a FOLDE is a DE or a differential equation with the given standard form dy dx plus y p of x is equal to q of x. So right here we can see that this standard form right here, we actually need to take note of two standard forms because a FOLDE has two standard forms. This is one. So in this standard form, the dependent variable y is the dependent variable in this derivative. So that is one way we can memorize this formula, is that the dependent variable y right here is on top, and whatever is the dependent variable right here, that would be the variable right here. So this is derivative of y, this is y, and whatever comes next is just in terms of x. So p of x is the next ones, so we also have q of x. So basically, whenever you start with the derivative of y with respect to x, then next would be adding y, and whatever comes next are just functions of x. So that's one way in order for us to actually take note of or memorize these formulas. So this is the FOLDE in y. So this is the FOLDE in y. Now we also have another form, the dx dy plus x p of y is equal to q of y. The standard forms here are actually quite similar. The only difference between the two is that the second one starts with dx as the numerator, so dx dy, and whatever is in the numerator, that is x, you will also add that as x right here, and the next ones are just in terms of y. So we basically just flipped everything in comparison of these two. For the first one, we started with y, added y, and then multiplied in terms of x. Now the next one, we started with x, we added x, and multiplied in terms of y. Multiplied functions in terms of y. So this is called the FOLDE. This is called the FOLDE in x. Now, given these standard forms, we can find the general solution or the respective general solutions for the specific FOLDE or the specific standard forms. Now we have two general standard forms we need to take note of for the general solution of these FOLDEs. So basically, when solving a FOLDE, we are given a FOLDE, then we need to make it into a standard form of these FOLDEs. Then, after we made it into a standard form, we can now find for the general solution using these formulas. So the first one, so this is the general solution formulas. The first one is this one. So for the FOLDE in y, we can see that the FOLDE in y includes functions of x. So what we're gonna do is we're gonna start the first formula for the solution of FOLDE in y, for the general solution of FOLDE in y, with a function of x. So what we're gonna use is phi of x as that function. Now phi of x right here is actually the integrating factor, which we're gonna be writing the formula after we have completed the actual formula for the general solution. So phi of x, so we started with a function of x, then we're gonna multiply this one with just reversing the variable of whatever is inside the function. So in this case, we started with phi of x. Now we're just gonna reverse x, so we have y. Okay. Then afterwards, we're gonna equate this to the integral of phi of x q of x dx, where, so this is where we're gonna show the formula for phi of x. Phi of x is equal to e raised to the integral of p of x dx. Now for the next one, we have the general solution for the FOLDE in x. We have this formula. So the first one is, so we're gonna start with the phi of y. Okay, so basically when finding the general solution for a FOLDE in y or a FOLDE in x, basically just look at your FOLDE. If it has functions of y, you start with this formula, and when you have functions of x, you start with this formula. So for the FOLDE in x, we have functions of y, so we're gonna start the formula as like this, no? So function of y or phi of y times reverse y, so that's x, is equal to integral of phi of y q of y dy, where phi of y is equal to e raised to the integral of p of y dy. Okay, so that's it for the definition of a FOLDE and the standard form and the general solution formulas. Okay, so now let's have our first example for FOLDE. So we have x dy dx minus 2y is equal to x cubed cosine 4x. So what we're gonna do here is first, we need to find a standard form for the FOLDE. So in order to do that, let's first try to mix in everything we have. So let's first try to put everything to the left side of the equation. So let's first subtract both sides, the x cubed cosine 4x, in order to be able to transpose the x cubed cosine 4x. So what we're gonna have here is negative x cubed cosine 4x is equal to 0. Now when looking at our differential equation or our FOLDE, what we're gonna have to have is that we're gonna have these forms: the FOLDE in Y or the FOLDE in X. Now, two things are the same or distinct, or two things are common between these foldes. The first one is that they both have an isolated or a derivative that is not multiplied to any coefficient or to any variable. So that's what we want to do. So in order to do that, we need to be able to multiply both sides by 1 over x so that we can actually cancel these out, and we can place the x right here as the fraction of these three. So we're gonna have dy over dx minus 2y. So we can actually make this into one fraction, this whole 2y minus x cubed cosine 4x. So what we're gonna do is we're gonna factor out the negative sign. We're gonna place that right here, and we're gonna make a very big fraction, which has the denominator of x. And then we're gonna just write 2y plus x cubed cosine 4x is equal to 0. Now our goal right here is that we need to have a y. So our standard form for the dy dx, let's look at the dy dx one, FOLDE in y. Our goal for FOLDE in y is that we need to have something like this. So we need to have, when we have already the derivative dy dx, we need to have to add this dy dx to a y. So we need to have something like this. So in order to have that, let's try to manipulate this whole fraction. So this whole fraction, we can actually separate it into two fractions, namely this first fraction and this second fraction. So when we do that, let's try to distribute negative sign again. So we have negative 2y over x. We have this whole negative 2y over x. Then let's distribute the negative sign again to x cubed cosine 4x. So we have this whole fraction right here. So we're gonna have negative x cubed cosine 4x over x is equal to 0. So why did we do that? That is because we want y to be on just one term. And when we have one term of y, we can just factor out everything else besides y. So what we have here is negative 2y over x. We can actually just factor out y and just have the negative 2 over x multiplied to the y. So negative 2y over x, we made it something like this. Now what does this look like? This looks like y p of x. So that's our goal. That looks like y p of x. Now afterwards, we have another function right here. What we can see is that this function right here only contains x variables. So we can consider this function right here as our q of x. So your goal here basically in solving a FOLDE is that you just need to be able to determine if it is a FOLDE in y or a FOLDE in x. In our case, this is a FOLDE in y because the derivative has the dependent variable y, and we add a y. Then the next ones that we're gonna have here is that when you isolate the y right here, then you will multiply it by a function x. This is the function x, so this is p of x. Actually, this is p of x. Now the rest of the equation just contains x. So in order to have the standard form, the actual standard form of a FOLDE in y, we need to transpose or add both sides, this whole term, onto the other side of the equation. So we're gonna have x cubed cosine 4x over x. Now this is q of x. So now we have the standard form for the FOLDE in y. Now that we have the standard form for the FOLDE in y, we're now gonna have to find the general solution for our given standard form. So we're gonna have the formula for the FOLDE in y. This is the formula. So it is a good practice to always try to first write the formula, even if you know the formula, so that it just aligns well, or you're just gonna have to substitute everything that you have in your standard form. So we have the formula for the general solution. Let's start the general solution. The formula for this one is that we have functions of x. So this is how we're gonna write the formula without having to memorize it. So we have functions of x. So you're gonna start your formula with a function of x. So in our case, what we're gonna use is phi, or our integrating factor. So phi of x times reverse x, so we have y is equal to integral of phi of x q of x dx. Where phi of x here is equal to e raised to the integral of p of x dx. Now let's try to solve for the general solution. So first we're gonna have to find phi of x. So phi of x is equal to e raised to the integral of p of x. Now we already know p of x. P of x is this one, or this one. So we have negative 2 over x dx, which is equal to, take out the negative sign, the negative 2, so we have e raised to the negative 2 integral of dx over x. Now this is equal to e raised to the negative 2 ln of x, which when we simplify, we have the property of the logarithm that if we have a constant multiplied to the ln of an argument x, let's say, then the constant is gonna be the exponent of that argument inside ln. So e raised to negative 2 ln x will become e raised to ln x raised to negative 2, where we also have the property of the logarithm that if we have e raised to ln of a variable or anything of or any algebraic expression inside ln, then we're just gonna have to remove e raised to ln and just take down this x raised to negative 2 or this algebraic expression. So we're gonna have x raised to negative 2 as our phi of x. So phi of x is x raised to negative 2. Now that we know the phi of x, we have everything that we need in order to use this formula. So we have phi and we have q. Q is this one. So let's try to substitute what we have on the general solution formula. So phi of x, x raised to negative 2, times y. So we're just substituting everything right here. X raised to negative 2y is equal to the integral of x raised to negative 2 times our q here is this one. So we have x cubed cosine 4x over x dx. Now let's just simplify. We have x raised to negative 2y is equal to, now x raised to negative 2 over x, you can actually make x raised to negative 2 as x cubed cosine 4x. X raised to negative 2 is basically just x squared when you try to use the reciprocal. So let's put x raised to negative 2 on the denominator and make it x squared times x. So x squared times x on the denominator becomes x cubed. Now you can cancel these out, these two. So you have x raised to negative 2y is equal to integral of cosine 4x dx. Now what we're gonna have to do is we're gonna have to integrate this one. So the integral of cosine 4x, one shortcut that we can use is that if you have a linear equation inside, let's say a trigonometric function cosine 4x, normally you would use u substitution, but we can have a shortcut where if you have something like this, you can just take the reciprocal of 4 or the coefficient of the degree of the variable holding the degree 1, then basically get the integral of cosine, so that is sine, and just copy the argument for x. So that's one shortcut that we can use, plus c. Then afterwards, we can isolate y. So in order to isolate y, we're gonna divide both sides by x raised to negative 2. So we're gonna have y is equal to 1 over 4 x raised to negative 2 sine 4x plus c, or you can write this as x squared over 4 sine 4x plus c. So this is now our general solution. Okay. Okay, so let's have another example. Y dx dy minus 2x is equal to y cubed cosine y. So the first thing that we're gonna do is that let's observe first the given example. The given example, we have a dx over dy. So let's try first to find the standard form of this dx over dy FOLDE. So in our case, this is a FOLDE in x, right? So what we're gonna do is first isolate this dx over dy, since any of those two standard forms that we mentioned before, they didn't have any coefficients or any variables that are multiplied to them. So in order to remove the y here beside the dx over dy, let us multiply both sides by 1 over y. So when we multiply both sides by 1 over y, we're gonna have dx over dy minus 2x over y is equal to y cubed cosine y. Now, for a dx over dy FOLDE, what we're gonna have is that we're gonna have to we need to have an x added right here. So we're gonna need to find something like this. So in order to search for that or have that, we can actually manipulate this negative 2x over y. We can actually factor out x, then the rest would be just negative 2 over y. Then for the right side of the equation, we just copy. Now we can see that we have this one as our p of y and this one as our q of y. So this is a FOLDE in x. Now next thing that we have to do is that we're gonna have to find the general solution. So to find the general solution, we have these formulas, or this formula. So since we have this standard form with y functions, then we're gonna start our general solution formula with a function of y as well. So we're gonna start with phi of y is equal to, is multiplied to reverse y, so that is x, is equal to the integral of phi of y q of y dy, where phi of y is equal to e raised to the integral of p of y dy. Now, your phi of y, we're gonna have to solve first for phi of y in order to complete what we need to have in this formula. So phi of y first is equal to e raised to the integral of, our p is negative 2 over y. So we have negative 2 over y dy. Then we basically take out the negative 2, so we have negative 2 times dy over y. The next would be to find the integral of this, so we have e raised to negative 2 ln y Property of logarithm again, we have e raised to ln y raised to negative 2. And again, this becomes y squared, or sorry, y raised to negative 2. So we have phi of y equal to y raised to negative 2. Now that we have phi, let's try to substitute that to our general solution formula. So we're gonna have phi of y is y raised to negative 2. So we're gonna have y raised to negative 2. Let's just move here. So we're gonna have, let's just copy this one. So we have our phi of y is equal to y raised to negative 2. So let's substitute this to the general solution formula. We're gonna have y raised to negative 2 times x is equal to the integral of y raised to negative 2 times q of y is y cubed cosine y dy. So let's just simplify. This is gonna be x over y squared is equal to y raised to negative 2 times y cubed. This actually just becomes y. So this is y cosine y dy. Now y cosine y dy, in order to actually integrate this, we need to use a technique called IBP, or the integration by parts. The integration by parts technique is actually one solution for a product of two expressions, in our case y and cosine y. So we're gonna have to pick between y being our u or cosine being our u. So the u one is the one that you're gonna have to differentiate, and the cosine one and in the dv1 is the one that you're gonna have to integrate. So let's choose y as our u, because y is relatively easier to differentiate, and when you actually try to integrate u, it actually becomes larger, which is, or when you actually try to integrate y, it actually becomes larger, which is not what we want. We want it to be easier to be solved, So let's choose y as our u and dv as cosine y. Then du, or the derivative of u, is just 1 dy, or this is just dy, and v is the integral of dv, which is sine y. Now let's have the formula for IBP. You have the integral of uv, or udv, is equal to uv minus the integral of vdu, uv minus integral of vdu, where your u is just y and your cosine y is y dy is your dv, which is equal to u y and v sine y minus integral of v, which is sine y, and du, which is dy. So when we try to integrate this, we have y sine y. So let's try to simplify. The integral of negative sine y so let's include the negative sign right here, is cosine y. So we're gonna have positive cosine y plus c as equal to the integral of y cosine y dy. So let's go back to this part right here. So let's go back to the general solution. We have x over y squared is equal to the integral of y cosine y dy, which is now y sine y plus cosine y plus c. Now our goal here is to first isolate x, since this is a FOLDE in x. One of the things that we can do, but not necessarily that we have to do, is we can isolate x. So in order to isolate x, we need to multiply both sides by y squared. So let's multiply both sides by y squared. So we're gonna have x is equal to y cubed sine y plus y squared cosine y plus c y squared. So this is now our general solution. Okay, so that's it for the first order linear differential equations. Thank you.